So, good morning, everyone. Welcome to our maths class. And if you remember, in last class we discussed about the limits, and in last moment of the class, a small discussion was there about derivative also. So today I am going to discuss about the differentiation and how can we differentiate the given function and what is the differentiation. All these things we'll discuss here. So just I'm going to start differentiation and first we will discuss about the differentiation of a function at any point, and then after differentiation of a function on the given point. Suppose that fx is the function. If fx is the function, then f dash x will be the differentiation of this function. It can be written as d dx of fx also, means the differentiation of fx with respect to x. It can be written as limit h tends to 0 fx plus h minus fx upon h. And at the same time, if I want to find the differentiation of function at given point c, so f dash c will be the differentiation of fx at c, that is equal to limit h tends to 0 fc plus h minus fc upon h. Now, if what will come existence of the derivative, that the given function can be differentiate or not, so we will find the left hand derivative and right hand derivative. Suppose that I am taking a c, and at a point c I want to check whether the given function is differentiable or not. So in this case, left hand derivative should be equal to right hand derivative, then only that function will be differentiable. And left hand derivative will be what? Limit h tends to 0 minus fc plus h minus fc upon h, and this one can be written as limit h tends to 0 plus fc plus h minus fc upon h. And the rest of the thing what we had learned in a left hand limit and right hand limit, the same thing I'll follow for this one minus also. So that was an important thing, how to find the differentiation of a function or derivative of a function at the given point. Your first exercise is totally depend on this one, and then after I'll discuss about ddx of fx also, and too many formula we are having, and the proof of all the formula will come with the help of this formula only. That ddx of fx, limit h tends to 0 fx plus h minus fx upon h. So in the starting of the I can say that I am having some question in the first exercise. What we have to find, use the definition of the definition and find the derivative of all the following function at the given point. Let me tell you one thing. The first one you can see, I am having here fx is equal to 3x, and I have to find the derivative at x is equal to 2. Okay, so what should I do? I can write here f dash 2 is equal to limit h tends to 0, that is the first question, h tends to 0, h tends to 0 f 2 plus h minus f2 whole upon h. Now when I'll put f2 plus h in the function, that will come like that, 3 2 plus h minus 3 into 2 whole upon h. And now when I'll simplify, it will be h tends to 0 6 plus 3h minus 6 whole upon h. They can eliminate. Limit h tends to 0, and this one can be cancelled. I'll have 3, that result will be 3. So differentiation of fx means 3x at x is equal to 2 will be simply 3. I want to do some more question for you people. one quadratic one I want to do, and that okay it will be easy to solve the other question, because just it is an introduction. After that we are having different type of question what we have to do today, and many other things are there. Algebraic differentiation will take place, so I'll discuss all these things in today's class. That was the question number first part. Now question number first, you can see sixth part is there. It is fx is equal to x square plus 2x plus 7. Yeah. If you are having any doubt to find f2 or f2 plus h, no problem is there. First of all, before writing this formula, I can find here. Since I have to find the differentiation at x is equal to 3. So I can find firstly f3, that is equal to 3 square plus 2 into 3 and plus 7. Yeah. It can be written as f3 plus h, that is equal to 3 plus h the whole square plus 2 into 3 plus h and plus 7. Now I want to find the derivative at x is equal to 3 of fx. So what can I write? F dash 3, it is equal to limit h tends to 0 f3 plus h minus f3 whole upon h. Now when I substitute the value of this f3 and f3 plus h, I can get here 3 plus h the whole square plus 2 into 3 plus h and plus 7 whole upon h. So limit h tends to 0, h tends to 0, and that is, I can write here, sorry, minus 3 square plus 2 into 3 plus 7. So when I'll simplify it, I'll get here 9 plus h square plus 6h plus 6 plus 2h plus 7 minus 9 minus 6 minus 7 whole upon h. So I think 9, 9, 6, 6 and 7, 7 can be cancelled. And whatever terms are there with us, in these terms, I'll have h common. So limit h tends to come 0 and h will be common. So h plus, I'll have a 6 and h will be common. 6 plus h 2 will be what? 8h. So I can write here 8 and whole upon h. They can eliminate. Now you can put h is equal to 0. So 0 plus 8, that is equal to 8, I can say. Very simple to find. After using this limit, and we can easily find that derivative at the given point. Now few more questions are there where we have to prove something, and then after I am moving to discuss some other question. Question number 3 you can see, and then after I'll tell you one thing, that what is the first principle and how to do a question by using first principle. Now, at question number 3, you can see, in question number 3, I am having fx is equal to x square minus 6x minus 7. I have to prove that f dash 5 minus f dash 3 is equal to f dash 8. This one we have to prove. What should I do? First of all, I want to find f dash 3, since f dash 3 is equal to limit h tends to 0 f3 plus h minus f3 whole upon h. It can be written as limit h tends to 0. At the place of x, I'll put here 3 plus h the whole square minus 6 into 3 plus h minus 7 minus 3 square 6 into 3 and minus 7 whole upon h. Now we can simplify, and then it is h tends to 0. It's a 9 plus h square plus 6h minus 18 minus 6h minus 7. Okay, and here also by using this simplifying, minus 9 plus 18 and plus 7 I can write, and whole upon h is there, 7 7 18 18 9 and 9. Now rest all the numbers, you can see that in each and every term 6h and 6h can be cancelled. So I am having only this one, that is equal to 0. I can get it is 0. Now I can find f dash 5. Okay, so f dash 5 will be what? Limit h tends to 0. Directly I am writing here f5 plus h minus f5 upon h. Now it can be written as limit h tends to 0, 5 plus h square minus 6 into 5 plus h minus 7 minus 5 square and 6 into 5 minus 7 again whole upon h. Now we must simplify it, and you will get here limit h tends to 0. That again it is 25 plus h square plus 10h minus 30 minus 6h minus 7 minus 25 plus 30 and plus 7 whole upon h. And you know what will happen? 7 7 will cancel, 25 25 will cancel, 30 and 30 will cancel. Then I'll have now limit h tends to 0. When I take h common, it is h plus 10 whole upon h. They can be cancelled. When it is equal to 0, it is 10. Now we had got f dash 5 as a 10. Now I'm just going to find f dash 8. F dash 8 will be f8 plus h minus f8 and whole upon h will be there. So sorry, limit also, that's I forget to write here limit f dash 8, that is equal to limit h tends to 0. Now if I write here limit h tends to 0, what can I see? 8 plus h the whole square minus 6 into 8 plus h minus 7. It will be in one bracket, and other bracket I can write 8 square minus 6 into 8 and minus 7 whole upon h. Limit h tends to 0. 8 square plus h square plus 16h minus 48 minus 6h minus 7 minus 64 plus 48 and plus 7 whole upon h. You can see here that 64 can be cancelled, 48 cancelled, 7 cancelled. And whatever I am having left, I can see h tends to 0. H 16 minus 6 will be 10. So I'll take h common. I'll get h plus 10 and whole upon h. They can be cancelled. Yeah. They can be cancelled. And now you can see when I put it is 10. So what we have seen, f dash 5 minus f dash 3, that is equal to 10 minus 0, it is equal to 10, and it can be written as f dash 8. So I have got our proof easily. Now few more things are there what I will discuss with you people. That's a differentiation function by first principle. What is the first principle? I think in the starting of the class I told you f dash x is equal to limit h tends to 0 fx plus h minus fx upon h. It was written something like that, that the differentiation of a function at any point, at any point. So if there is any function and I want to differentiate that function by the first principle, why I am using this word, let me tell you a few things, then it will be little bit easy for us. All these questions what I have done till now, that differentiation at a given point, it can be done by another method also, that by using the formula. And next exercise I'll get to use the formula and how to differentiate the given function by using the formula. Let me tell you few things, and then again in next exercise we will discuss about this formula, and okay, after using formula all these things will be very easy for you. Listen me carefully. Actually, ddx of x to the power n can be written as nx to the power n minus 1. It means the differentiation of x to the power n with respect to x can be written as nx to the power n minus 1. Suppose that I am having fx is equal to x to the power n. So f dash x can be written as ddx of x to the power n, and that directly I can write nx to the power n minus 1. This is the formula of x to the power n, differentiation of x to the power 1 n with respect to x. But at the same time, if we want to write the differentiation of x to the power n by using first order derivative, what should I write? ddx of x to the power n can be written as limit h tends to 0 x plus h to the power n minus h to the power n upon h. Now question has come from where it has come. I think in starting of class I told you that differentiation of a function at any point, it was something like that f dash x, that was written as limit h tends to 0 f x plus h minus fx and whole upon h. So if I am finding the differentiation of any function by using this one, I can say I am finding the differentiation of the given function by using first principle. This is called the first principle. Okay, I am going to solve one question for you people that depend on the first principle here, and hope you will get all these things very easily. Now see, our first question is question number 4. There are 11 part in question number 4, and in each and every part simply it is written to differentiate the given function by using the first principle. I'm going to do that second part firstly. Question number 4th, second part is there. Here I am having fx is equal to 3x minus 5. Definitely fx plus h can be written as 3x plus h minus 5. I can write. Now, if I want to find f dash x, I can write limit h tends to 0 fx plus h minus fx whole upon h. Easily I may write. So when I substitute the value of all these, limit h tends to 0, 3 x plus h minus 5 minus 3x minus 5 whole upon h. Limit h tends to 0, it's 3x plus 3h minus 15 minus 3x and sorry, it's not minus 15 because that 3 will multiply here only, and plus 5 whole upon h. I think they can cancel. I am having 3h upon h, that h cancel. So result will be 3 only. Now this is the differentiation, and same thing as I told you in one formula na, that d dx of x to the power n is equal to nx to the power n minus 1. If I'll use the same formula to find the differentiation of this one, so I'll use here d dx of 3x plus 5, it means 3 d dx of x minus d dx of 5. The differentiation of constant term will be 0. This thing I will discuss later on. Here I am having power 1. 3 into power will come first, and in power 1 we have to subtract that minus 0. So 3x to the power 0, again I will get 3. So this is by using formula, but we have not discussed till now all these things. I will discuss all these things again in next exercise. But by using the first principle to find the derivative of any function, I'll use this one only. One more question I want to do depend on this, that a little bit different. That is, if we will have something in a fraction. Last one you can see x. I'm having fx is equal to x plus 1 upon x. Fx plus h is equal to x plus h plus 1 upon x plus h. I have to find the derivative of this fx. So what can I write? F dash x is equal to limit h tends to 0 fx plus h minus fx and whole upon h. When I substitute the value of this one, x plus h plus 1 upon x plus h minus x and minus 1 upon x. This is h. Do you know, my dear students, I may write x and x can be cancelled. So I am having now h tends to 0, h plus here, if I take x plus h as LCM here and x, so I'll get x minus h. They can eliminate, and whole upon h is there. If I'll take h common here, I may write 1 minus 1 upon x plus h into x whole upon h. They can eliminate. H tends to 0. If I take h tends to 0, I'll get simply 1 minus 1 upon x square. 1 minus 1 upon x square I'll get easily. So these are the few things what I want to discuss with you people, and now I'm going to discuss with you about the some standard formula which will be used in the next exercise. So if I'm having a function and we want to differentiate it with respect to x, so we have to follow the following formula. What I am going to tell you, if I am having any constant term, so differentiation of constant term can be written as 0. Differentiation of constant terms will be written as 0. Now, few things are there in front of you. You can see, as I told you previously, if I am having somewhere f dash x, this one can be written as d dx of fx, means the differentiation of the given function with respect to x. Now, in this series, few formula is there. The first thing is there कि if I am going to write the differentiation of a constant term c, that will be always 0. Either it is 1, 2, 3, 4, 5, 6, whatever is there, but differentiation of a constant term will be always equal to 0. Then after, the first important formula is there, dx of x to the power n. It is n x to the power n minus 1. For example, if I am having somewhere ddx of x, so power will be 1. I can write 1 into x to the power 1 minus 1, 1 into x to the power 0, that is 1. So we had got one cons formula that the differentiation of a given function with respect to x is always like that, n x to the power n minus 1, and the differentiation of x with respect to x will be 1. Then after, we are having few more formula to discuss with you people, and suppose that I am having, as I told you, ki constant differentiation of constant will be 0, differentiation of any function will be different. If I am having d dx of a constant into fx, so it can be written as c into d dx of fx over, means if the constants will come as a multiple of a function, so that constants can come out and we have to differentiate that variable, means x and all these things. Few more things are there. If I am having two function, it is fx plus gx r minus gx, no problem is there. I can write ddx of fx plus minus ddx of gx. But at the same time, if I am having this gx and fx in a product form, then things will be changed. Suppose that I am having ddx of fx into gx. This is called the product rule. This is called the product rule. So I can write here fx into ddx of gx plus gx into ddx of fx. Or in other word, I can took it as first and second. So I can write first into second differentiation plus second into first differentiation. At the same time, we can write ddx of fx upon gx. It can be written as that gx square gx into ddx of fx minus fx into ddx of gx. To make it more easy, I may learn in this form ddx of numerator upon denominator, means of fraction. So simply I can write here denominator is square, denominator into ddx of numerator minus numerator into ddx of denominator over. So these are the few things what I want to discuss with you people in this exercise. And now I'm going to discuss some question, and few more things are there to discuss, like differentiation of a function to the function, That is, we will follow that some chain rule. And then some more formula are there that's related to trigonometry, differentiation of the trigonometry ratios, differentiation of the exponential, differentiation of the logarithm. So many things are there. So let me discuss all these things, and then after I'll move to the formula question. If suppose that I'm having somewhere ddx of e to the power x, no problem, it will be e to the power x only. If I'm having somewhere ddx of log x base e, it can be written as 1 upon x. If I am having somewhere ddx of log x base a, it is 1 upon x into 1 upon x into log a base e. If I am having somewhere ddx of a to the power x, it can be written as a to the power x into log a. If I am having somewhere ddx of sine x, it can be written as simply cos x. ddx of cos x, it can be written as minus sine x. ddx of tan x, it can be written as sec square x. ddx of cot x, it is minus cosec square x. ddx of sec x, that can be written as sec x tan x. ddx of cosec x, it can be written as minus cosec x into cot x. In this exercise, only one logic is left, only one point is left, that is differentiation of a function with respect to a function. Okay, sorry, if a function like I want to tell you one thing, I learn here ddx of x to the power n. ddx of, suppose that I am having 2x square plus 3x whole to the power n. Now here 2x square plus 3 is working as a variable, and that 2x square plus 3 is a function of x. 2x square plus x to the power n is the function of 2x square plus 3. So it is called the function of a function. So that's I'll discuss in the next class, and in the next class only, as we have discussed so many formula. So today I am giving you one homework to learn all these formula. Then only when we will discuss about the exercises, when I'll solve the question, there are in 13.5 I can say there are 25 question. Out of these 25, that first 24 we have to solve by using the formula, but the last question 25th we will use the first principle to find the derivative of the given function. We have to use the first principle. Okay, but side by side always you should keep in your mind that is in a differentiation, that in starting, that is a basic thing I can say. So this formula whatever I have written here, it will be important for you. As I told you, the differentiation of constant term will be 0, the differentiation of x to the power n and x to the power n minus 1, then few more function, then some algebraic concept of the differentiation. If two functions will come in the form of product, what will happen? If two functions will come in the form of quotient, then what will happen? All these things I have discussed. So today's work, you should just try to solve the first exercise, and after solving the first exercise, learn all these formula, because in next class I'll use this formula, and definitely if you learn all these formula, it will be easy to solve the question of next exercise. Okay, thank you, have a good day.